Good morning. Today I'm going to talk about the effect of electrical charge on the structural and vibrational properties of gold-60. The electrical charges we used were of -2, neutral, and +1. In addition, we characterized by a vibrational calculation showing a specific traits on the IR and Raman spectra. The gold-60 exhibited two types of symmetry, demonstrating that metallic clusters need not to come in compact structures with high symmetric degrees. The coding of polyhedrons and the study of the geometric relationships give us a greater ease in the comparison and quantification of the distortion that occurs in the structures. Our studies were based on the FT theory using ORCA software. In this figure, we can see in the upper part the graphical representation of the dication that has the characteristic of being a singlet. The three structures in the middle represent the anion that together with the dication presents a CS symmetry, but unlike the dication, it is a doublet. And the last figure corresponds to a neutral charge with greater symmetry and with a singlet electronic spin state. Here we can see the graphical representation of the bond lengths of the gold-60 clusters. In the upper part, we can see the bonds of the dication, in the middle part of the anion, and in the last part of the neutral charge. At first glance, a greater symmetry can be noticed in the last graph since it has a range from 2.66 to 2.77 angstroms, while the other two graphs show a greater relationship with them over the range of lengths of their bonds. In the figure 3, we can see the bond lengths of the blocks into which the gold-60 cluster were divided. The blocks are made up of octahedra and tetrahedra in a range from 2.7 to 3.4 angstroms. We can notice a greater distortion in the middle graph than the other ones, and at the same time we can observe a figure almost perfect with just a variation of 0.10 angstroms. In the other picture, we can see the angles of the blocks into which the clusters of gold-60 were divided, with a range of 50 degrees to 75 degrees. And as the same way, we can notice that the anion presents a greater distortion and the neutral has values closer to 60 degrees. The IR spectrum, where the red lines correspond to the dication, the blue ones to the anion, and the green ones to the neutral, we can see that the red and the blue graphics have peaks at almost same frequencies, while the green one has a peak at a smaller frequency, but with a greater intensity, which is associated with tangential normal modes. Also, we can notice that the anion has a peak frequencies of 105 that we can see a peak at almost 105 frequency that is not seen in the other two graphs. We can see a peak at a frequency of almost 105 in the middle graph that is not shown in the dication and the neutral graphics. The Raman spectrum follows the same pattern of identification that the IR spectrum, and also shares some similarities with it. Like the dication and the anion share a peak at a similar frequency, and the neutral has a greater peak but at a smaller frequency, and it is a breathing mode. We conclude that the polyhedral analysis is sensitive to the distortion, even more than the bond length graphs. Furthermore, it is remarkable that each symmetry has a characteristic IR and Raman spectra, which should allow us to identify them experimentally. Thank you.